In this video, we are going to be solving 40 physics questions that were asked in a set in the JAMB 2024 exam. Okay, now we're having the first 10 questions on the board, but before we go into it, you should know that majority of these questions here are basics, and to best understand it, you might have studied these topics, okay, in your physics O level using various materials and textbooks to give you the best understanding, okay. But if you just want to practice questions or see how questions are being asked in JAMB exam, you are in the right place. Now, for those persons that are just joining us, you might want to subscribe to YouTube channel Dr. Flash so that when new videos are being uploaded, you'll be one of the first two persons that will get notified about it, especially if you're writing the JAMB exam, the WAEC exam, the NECO, your A and O level exams in general. Now, the first question on the board says, the stress experienced by a wire of diameter y over pi centimeter, so the diameter of the wire is y over pi, loaded by a weight of y squared newtons. So the weight that was applied to the wire was y squared in newtons, okay? Now, they're asking us the stress. Option A, is it pi newtons per meter, 2 pi newtons per meter, 4 pi newtons per meter, and then 8 pi newtons per meter? So which of these options? Now, to solve a problem like this, first things first, you need to take note of what is being asked to find and what is given. Now, what we are being asked to find is the stress, okay? Now, stress is a concept you find under the topics Hooke's law or elasticity of solids, okay? Now, stress has its own formula. The formula for calculating stress is force over area, okay? So the force or the weight that is applied to the solid or material divided by the area in which the force is applied to give you the stress, okay? Now, the force in this case was given as y newton squared. But then how do we solve for the area? Since we are given diameter, okay, in the question, our mind should simply go to the fact that we can solve with the area, we can solve for the area rather by using the formula for calculating area of a circle, okay, since diameter was given. Assuming our general dimensions were given like length and breadth, there would have been more emphasis on the kind of shape so we can solve for the area. But when you are given diameter, especially for solids like wires and the likes, to calculate for the area, we use the area of a circle, okay. Now, we do know that the area of a circle is pi r squared. Now, what is r? R was not given, but we know that r is half of the diameter. So when we divide y over pi by 2, we get the radius, okay. So to get the radius, which is diameter over 2 is equal to, diameter in this case is y over pi. It means y over pi divided by 2 gives us our radius. That means radius is equal to, dividing y over pi by 2, that gives you y divided by 2 pi. We can then solve for the area. Now, to solve for the area is equal to pi r squared. Now, r is y over 2 pi, so we have y divided by 2 pi all squared. This simplifies to area is equal to pi times y squared divided by 4 pi squared. Pi cancels out pi, so we're left with y squared over 4 pi. So you notice that the area for the shape or the wire that is given in the question is y squared over 4 pi. Now, the force on the other hand is given as y squared newtons. So to find the stress, we divide the force by the area. That means the stress is equal to, the force in the question was given as y squared divided by y squared over 4 pi, okay. From this place, we have to do our normal maths, okay. To turn system multiplication, this one goes up and this one comes down. So we're then going to be left with, okay, we're then going to be left with stress is equal to y squared times 4 pi over y squared. Y squared cancels out y squared. This simply means that the stress is equal to 4 pi, and that is option A. So that is how problems like this are being tackled, okay. You can as well study more on elasticity and Hooke's law to gain more understanding on the concept of stress. The next question on the board says, under which condition is work done? So having various options are being asked, under which of these conditions is work said to be done, okay. Now the first option here rather says, a man supports a heavy load on his head with his hands Okay, now you need to understand the concept of work, or when work is said to be done. Now, work is said to be done in general when a force is applied through a distance. Okay, work is not said to be done when there is only a distance in the situation. Okay, it is not said to be done when there is only force that is being applied. Yes, the man is carrying a load on his head or with his hands. There is a force that is being applied, but he's not moving through any of the distance. Okay, he's not moving through any distance because it was not stated in option. This simply means that option A is definitely what now? Wrong, because they said a man supports a heavy load on his head with his hands. Okay, there is a force that is being applied there, but there is no distance traveled, hence no work is done. Now, option B, a woman holds a pot of water. Now, if the woman holds a pot of water, there is no difference between option A and option B because the woman is not traveling through any distance. Hence, she is not doing any work. Option B is wrong. Now, option C on the other hand says a boy climbs into a table. Now, if someone is going to climb into a table, okay, it simply means that if this is the platform or the table and this is the person that is to climb to the table, the person is going to definitely move from his initial position. Okay, if he moves from here down to here, okay, it simply means that there is what now? A movement. Okay, and for there to be a movement, it simply means that distance is being covered. Since is going to require energy or a force against gravity to go from the ground level down to the top of the table, it simply means that there is a force. So we now say that there is both a force and a distance traveled. Hence, work is being done for option C. Now let's see option D to even see if it could be part of the answer. Okay, now a man pushes against a stationary petrol tank or petrol tanker. Okay, you should know what the petrol tanker is. Now, they are saying a man is pushing against the stationary tank. If I was to push against a car or a tanker and it moves, then work is being done. But since the question says stationary, or rather the option says stationary tanker, it simply means that work is not done. Even when force is applied, there is no distance moved, hence work is not being done. Now, question 3 says the mechanical advantage of the machine shown above is. Now, when you look at this machine, the first thing that should come to your mind is a wedge, because this is simply a wedge. Okay, if you studied machines in physics, you should know how to tackle a problem like this. We have been asked to solve for the mechanical advantage. To solve for the mechanical advantage for a wedge, there is a formula we use in solving for it. Okay, now to solve for the mechanical advantage, I'm going to come here and write mechanical advantage for a wedge. We do know that generally mechanical advantage is load over effort. Okay, but for a wedge, the mechanical advantage is giving us the length of slope, okay, the length of the slope divided by the thickness of the wedge. Okay, now the length of the slope is simply the slant length we are seeing. That is why you see that it's saying length of slope. Okay, and the thickness is simply what now? The thickness of the wedge. Okay, that is the distance from one end to the other one. Okay, so to get the mechanical advantage, you are simply going to divide the slope length by the what now? The thickness, and that gives us 15 divided by 0.5. And when we do that, what do we get? We're going to get an answer of 30. Okay, mechanical advantage doesn't have a unit, so when you look at the options, 30.0 to 1 decimal place is the correct answer. That is option C. So this is how a problem like this is being tackled. Now for question 4, the question says rainbow is formed when sunlight undergoes which of these options. Okay, now let's analyze which of these options, or each of these options rather. The first one says reflection. Now what is reflection? Reflection is simply the bouncing back of what now? A wave when it hits an obstacle. Okay, I'm going to make use of light since rainbow has to do with what now? Sunlight. Okay, so I'm going to say reflection is the bouncing back of light when it hits an obstacle. This simply means that if light is coming towards an obstacle that has a reflective surface, it is going to bounce back the light, and that is why we are able to see that surface. Okay, and we say the surface can what now? Reflect light. Although most surface can reflect light more than the other, they have different reflectivity. Okay, that is why some reflects more than the other. Example, a mirror. A mirror will reflect more light than this whiteboard we are having here. Okay, so that is reflection. B, we're having refraction. Now, what is refraction? Refraction is the bending of light. Okay, we're talking about sunlight in this case. That is why I'm not making use of the term wave. Refraction is the bending of a light wave, okay, as it moves between a pair of media. So if we're having two different medium, let's say on top we're having air and below we are having water. As light strikes this surface, what we notice is that it will bend. It is not going to move in this continuous straight path, which is in accordance to the rectilinear propagation of light, which says light travels in a straight path. We notice that it tends to bend towards the normal. Okay, there is a whole lot more explanations to this. Okay, at an angle, it's bent towards the normal. Okay, like I said, there's a whole lot more explanations to this. Okay, when light is moving from a less dense medium to a denser medium, it's bent towards the normal. So you notice that the initial path can be traced out like this. Okay, but it does not take that pattern. That is what we call what now? Refraction. And it does not cause rainbows. Okay, now let's take a look at option D, diffraction. Diffraction has to do with the bending of light around an obstacle. So let's say we are having an obstacle. Let's say we are having an obstacle like this, okay, with a small hole in between, and then as a wave approaches it, it hits this obstacle. But since there is a space inside, the wave is going to bend through the obstacle and then propagate out of it again. That is what we call what now? Diffraction. Or let's say we are having a block here, okay, as the wave comes, as it hits this obstacle, there is no space for it to go through. What it does is that it goes through this other part, okay, emerging through the remaining space. Okay, the wave has been what now? Diffracted. And then we have option C, which is the right answer to this question. But why is it the right answer? Dispersion simply means the spreading of light into its various components when it passes through a medium. Now that medium could be a glass, or it could be droplets of water. Okay, what happens in the atmosphere is that as sunlight, which is pure white radiation, passes through droplets of water that are being suspended in the atmosphere, okay, the droplets of water then disperse the white into its various colors, which you now see as rainbows. So for question 4, the correct answer is simply what now? Dispersion rather. Diffraction, which is option D, is wrong. So the correct answer is dispersion. Now the next question here is question 5. Find the value of a capacitor with voltage 5 volts and 30 coulombs. Okay, we are giving the voltage and we are giving the what now? The charge on the capacitor. The formula used in calculating the capacitance of a capacitor is the charge divided by the voltage. Okay, that is what we define as capacitance of a capacitor. The capacitance of a capacitor simply tells us how much charge it can store per unit voltage. Okay, so to solve for the capacitance is equal to charge, which is Q divided by voltage. Now the charge in this case is given at 30 and voltage is given as 5. So that is simply equal to 30 divided by 5. When we do the math, we are going to get 6. Okay, 6 farad. Farad is unit for measuring capacitance. So question 5, the correct answer is B, which is what now? 6 farads. The next question on our list says when a bus is accelerating, it must be which of these options? Changing its speed, changing its velocity, changing its position, and changing its direction. Okay, that is the question that is being asked. Okay, now when a bus is accelerating, generally we see that, or rather we define acceleration as the change in velocity with respect to time, right? That is what we define as acceleration. Now, the change in velocity with respect to time is defined as acceleration. Hence, our answer in this question should be option B. The reason why we are not picking option A, which is change in speed, simply because this guy here, acceleration, is a vector quantity, okay? And the best way to describe acceleration is the rate of change of another vector quantity, which is what now? Velocity. Okay, now it is actually possible for a body to be accelerating and its position will be changing, okay, and also its direction will be changing. Okay, it is also possible, but then generally when a bus is accelerating, okay, we are not told that the direction is being changed or is moving in circular paths which will change the direction. Okay, the question says when a bus is accelerating, it must be which of these? Changing its velocity. There is no way it's going to be accelerating without a change in velocity. So that is the best answer to the question. And then we'll have question 7. The question says the friction due to air mass can be reduced by which of these options? How do we reduce friction? Okay, but when you notice, when you look at the option, you notice that there is streaming, there is lubricating, and then there is polishing. Okay, which of these will best help to reduce friction? We also have a propeller. Okay, you should know what a propeller is. A propeller is simply like a fan that helps in creating drag in most aerodynamic objects. Okay, now which of these will help to reduce friction? Streaming will help to reduce friction. Streaming simply means streamlining. Lubricating also will help to reduce what now? Friction. But look at the question very well. The question says the friction due to air mass, that is when a mass is moving through space or air, which of these will help to reduce the friction? It is simply streaming. Streaming simply means streamlining. Now, we talk about streamlining, we're talking about the shape of aerodynamic objects that will help to reduce or help the object to attain the least possible friction available for it to move, okay, through space. So streamlining is the correct answer. Now, lubricating is also another way of reducing friction, but it is not the answer to this question. Why? Lubricating is simply done where we're having most times metallic parts that are touching each other, okay? That is when we use what now? Lubrication or lubricating. Now, question A says, which of the following operates based on magnetic effects of electric currents? Now, when you look at the various options, which of these operates based on magnetic effects? When we talk about cold cathode, this has to do with electrolysis, okay? There is no magnetic effect of current involved, so option D is already out. Now, we look at an electric heater. It works based on the heating effect of current, that is the ability for current to produce heat, which is in accordance with Joule's law. Okay, so option A is also wrong. And then we look at the photocell. The photocell comes into play when light falls on a metal, generating electrons, which can be used in various ways, okay, to create electronic device or electric bells. Why option C is the correct answer? Now, a dynamo is simply a device which converts mechanical energy into an electrical energy. That is what a dynamo does. It converts what now? Mechanical energy into what now? Electrical energy, and it does this in accordance with the Faraday and the Lenz law. Okay, and we do know that the Faraday and the Lenz law are laws that are being governed by the magnetic effects of current. That is, when there is a magnetic field, a current, then there is motion, or when there is a magnetic field and motion, then there is current that is being produced. Hence, the correct answer to this question is option C. How about question 9? Now for question 9, it says when a charged ebonite rod is brought near a charged glass rod, there will be which of these? Will there be an attraction, a repulsion, okay, a spark, or no force experienced? Now there is something I would like to explain, and I want you all to take note of. When a glass is rubbed against a foil or a silk, what happens? When a pipe or a PVC is rubbed against foil or silk, what then happens as well? Okay, it's important that you take note of it. Let's say on this part we are having glass, okay, and then we're having a pipe, and then we're having a silk, and then we're having a foil. Okay, now it's important that you take note of this material, silk. Okay, it might be the easiest way for you to understand when glass is rubbed with silk or foil, or when pipe is rubbed with silk or foil. Now, when glass is rubbed with silk, okay, when glass is rubbed with silk, silk generally it loses electron easily, simply because it has a very low work function. Okay, it loses electron to the material, hence the glass now becomes negatively charged. Okay, the glass becomes negatively charged. Now when glass is then rubbed with four tends to what now have a high work function. Hence, materials that are used to rub it, or when it is used to rub certain materials, it tends to what now get electrons from them. So when we rub glass with four, what we get is a positive charge. Okay, now pipe, when rubbed with four, will give something different. Okay, when pipe is also rubbed with silk, we are going to get something different as well. When pipe is rubbed with silk, remember I said silk tends to what now give us electron because of its low work function. Okay, when pipe is rubbed with silk, what we get is a negatively charged, okay, a negatively charged pipe, simply because it's going to give us electrons down to the pipe. Okay, so we're going to get a negatively charged pipe. When pipe is now rubbed with four tends to what now? Taking electrons. Hence, the pipe is going to lose electrons to the four. giving the pipe a positive charge. So that is what happens. Now, most JAMB questions, they don't ask you when glass is being rubbed with 4. Neither do they ask you when pipe is being rubbed with silk. What they usually ask you is glass to silk. Okay, so they will tell you when glass is rubbed with silk. These are the two that usually go together. And then they will tell you when pipe is usually rubbed with 4. These are the two that usually go together. So in most questions, they might not be specific about the material. If they are not be specific, take glass to be rubbed with silk. If it is pipe, take it to be rubbed with what now? 4. Okay, so in this case, when glass is rubbed with silk, we already explained that when glass is rubbed with silk, we get a negatively charged what now? Glass. So come back to the question. When a charged ebonite rod is brought near a charged glass, so we can now see that the glass rod what now is negative. The charged glass is what now? Negative. And then an ebonite rod. Now, take note that an ebonite rod is actually a vulcanized rubber. Okay, that is what an ebonite rod is, and we use it to transfer charge most times into different objects or materials that we want to be charged, simply because it has a very high non-conductance. Okay, it has a very high non-conductance. That is, it is highly insulating. That is why I usually make use of what now? An ebonite rod. An ebonite rod generally, they tend to be what now? Positively charged. Okay, we make them positively charged before we work with them. So take note that ebonite rods are generally what now? Positively charged. So if we are bringing an ebonite rod close to a glass rod, what do we get? A negative and a positive charge being brought to each other. We do get an attraction, right? So it simply means that the correct answer to this question is A, an attraction. Okay, now I'm going to take this off so it doesn't look confusing to the next question. Okay, if you need it, you can as well rewind the video to take note of it. And then we're having the next question, question 10. The question says, pilots use an aerodynamic barometer to know the height above sea level because. Why do pilots choose to use an aerodynamic barometer? Okay, now what is simply the reason? Because there are various types of devices that we could use to measure pressure, right? Because an aerodynamic barometer measures pressure, which in turn measures the height, because pressure varies directly as what now? As the height. Why then do they choose to use the barometer? Okay, now there are options here. Some say it is because it's very accurate, or option A says rather very accurate. Option B, small and convenient. Option C, heavy and huge. Option D, costly. Okay, I'll read the question again. Pilot uses an aerodynamic barometer to know the height above sea level because. Now, because it is very costly, it is impossible for this to be the answer. So obviously it is out. There is no way anyone wants to use something because it is very costly. Okay, we tend to, or rather we try to reduce the cost of production of these things. Okay, and then option C, heavy and huge. Okay, if pilots are to make use of items that are heavy and huge, it is of no use. Okay, so option C is definitely what now? Out. And then we're left with small and convenient, and they will have very accurate. Now there are more accurate barometers or pressure measuring devices. Okay, so it is not because it is very accurate, but rather we make use of it because it is small and convenient. Now this is the picture of an analog barometer which you are seeing on the screen. Okay, it is very small and convenient to use. That is why pilots choose to use an analog barometer when they are driving aerodynamics objects like planes, choppers and the likes. Over to question 11. The question says, a light ray passing from air to water at an angle of 30 degrees from the normal in air would, option A, make an angle greater than 30 degrees in water surface, okay, and then B, be completely absorbed by the water surface. Option C, be completely reflected by the water surface, and D, make an angle less than 30 degrees from the normal in water. Now let's see how this works. Let's say we are having a boundary and then light strikes the surface, of which the one we're having on top is air. Of course, there is a number that is being formed, and the one we're having under is water, just as the question said. Okay, when light strikes the surface, they said it strikes the surface at an angle of 30 degrees to the normal. Okay, now this is the number in air and this 30 degrees. Now we do know that since light is moving from air to water, it is moving from a region of lower density or lower refractive index to a region of higher density or a higher refractive index. Hence, it is going to bend towards the normal. Okay, you notice that it will what now be closer to the normal. Assuming it's remain on refracted, we would have had the same angle as 30 degrees over here, but since it's closer to the normal, you notice that the angle is smaller. Okay, so the angle is smaller and it is closer to the normal in the medium, which is water. Okay, when you look at the option, the one that best describes it is option D. It says make an angle less than 30. I just said it is closer to the normal, hence the angle is smaller, which is less. Okay, less than 30 from the normal in water, and that is what we just saw here. Okay, but when you take a look at the other options, there are other properties that could still be explained depending on the angle of incidence, okay, to the normal. Now, if I choose to bring this light ray, or let's say the light source, if I choose to bring it down, that is by increasing the angle of incidence, we'll notice that the angle of refraction starts moving at a speed down to this direction. Okay, it will start moving here. As I'm moving this one to this part, this guy starts moving here. Now it gets to a point or an angle that the light source make, or rather the light ray makes, with the normal, okay, in the air interface, okay, or in the air medium. It gets to a particular angle. Okay, I'm going to call that angle theta. Okay, it gets to a particular angle such that when the light ray makes that angle with the normal, the refracted ray lies exactly on this boundary. Okay, that was what happened. So as I'm pulling it down, this one is moving in this direction. It gets to an angle that this one now lies or makes 90 degrees with the normal. Okay, that is what happens. Now, if I choose to move it further, this one now becomes reflected upward. So if I choose to move it further, let's say to somewhere like this, refracted ray now becomes what now? Reflected upward. And then this angle theta is called the critical angle, and it is that angle where the refracted ray just makes an angle of 90 degrees with the normal. Okay, now you can use that to also pick your answer in this option when the question is quite different. Okay, sometimes, like when you look at the option, in this case option C says be completely reflected by the water. If it is completely reflected by the water, it simply means that the refracted ray now what now comes outside total internal reflection. So that is another question, or a way you can answer a question like that. Okay, that is for that. That means the option to the question is option D for question 11. Now question 12 says a solid cube of aluminium is 1.5 centimeter on each edge. Okay, the density of aluminium is 2,700 kilograms per meter. Okay, this should be per meter cube, kilograms per meter cube. Find the mass of the cube. That's what we're asked to find. Now we do know that density is equal to mass divided by volume. Since we are asked to find mass, you simply cross multiply to give you mass is equal to density times volume. Now you notice that the volume is not given in the question, but the dimension, as I say, it's a cube, not a cuboid. The difference between a cube and a cuboid simply means that a cube has all sides and dimensions to be equal, while a cuboid does not have all the sides to be equal. Okay, but it's still having several faces. Okay, this is what I'm talking about. We can use a square to simply construct a cube. Okay, it has how many faces? 1, 2, 3, 4, 5, 6. Now a keyboard also has 6 faces. Okay, a keyboard also has 6 faces. I will try and draw it here. Okay, something like this. 1, 2, 3, 4, 5, 6. Still 6 faces. Okay, that's the difference. One is being formed by a square and the other is being formed by a rectangle and a square. Okay, or rectangles. Now, the question says we should calculate the mass. And to calculate the mass, we need to know the volume. Okay. Now, how do you solve for the volume of a keyboard? Notice that all the dimensions are equal. The length, the breadth, and the thickness, they are all equal. Okay. Now, to calculate the volume, we are simply going to multiply the dimension of one side by itself 3 times. Okay. That is the volume of the keyboard is length times length times length, which is also equal to length to the power of 3. Now we're given the volume as 1.5. Remember, they are in different units. This one is a centimeter and this one is a kilogram per meter cube. And then the options are in grams. So it is important for us to convert this one to gram, okay, and then convert this one to meter. Now, to convert 1.5 centimeter to meter, we'll simply divide by 100 or multiply by 10 to the power of minus 2. Okay, so that's dimension. To find it in volume, volume will then be equal to 1.5 times 10 to the power of minus 2. So we have 1.5 times 10 to the power of minus 2 meters. We've converted, and then there's a cube in the formula cube. So that is the volume. Okay, and then the density, let's convert it into gram per meter cube. Okay, now kilo is 10 to the power of 3. So it means the density is equal to, the density will be equal to 2700 times 10 to the power of 3 grams per meter cube. Now we can now multiply both of them to get our answer for the mass. We said mass is the density times volume. So let's multiply these two guys and see what we're going to get. Now it is important that you take note that there will be no calculator allowed in your examination hall, okay? There will be no calculator allowed in there, whether scientific or non-scientific. There is an inbuilt calculator in the system that will help you solve quite a few problems. That is why it is important for you to get used to some mathematical formulas and expressions like a trig identities and the likes. Those ones will help you solve problems on calculation faster. So if you have to multiply this, I'm just going to use in simple setting on the calculator. When you do that, you get an answer of 9.1125. Okay, you get an answer of 9.1125, which is approximately 9.1 grams, of which is the correct answer. That is simply option B, 9.1 grams approximately. So that is how a problem on density is being solved. All you have to do is take note of the formula, of which density is mass divided by volume, put in your parameters that are given, and then we are good to go. Now, question 13 says, the value of R, now R here represents resistor, okay, required to make the galvanometer measure voltage up to 40 volts in the diagram above is, the question says, the value of R required to make the galvanometer measure voltage up to 40 volts in the diagram above is, now here is the diagram, okay. You notice that in this device, we're having a multiplier, which is a resistor, okay. We're having small r, which tells us it is having an internal resistance, okay. And then there is a current of 20 milliamperes flowing through it. We're asked to find the value of R that will make this setup to measure or work with a voltage that is up to 40 volts. Now there's a formula for calculating that. Okay, we do know that EMF, or potential difference of voltage, is equal to current in brackets internal resistance plus the external resistance. Okay, for me we are asked to find the external resistance. So if we make that the subject, we are going to be having big R is equal to E divided by I minus R. We are going to divide both sides by I and then bring R to the other side. So that's how you do it. Now, to solve for R, E in the question is given as 40 volts. It means we are going to have the resistor or resistance to equal 40 divided by, what is the current given in the question? 20 milliamperes. Milli in measuring unit simply means 10 to the power of minus 3. So we're going to convert. That will be 20 times 10 to the power of minus 3. Okay, minus the resistance, internal resistance given, which is what now? 10. So have minus 10. Now when you do the maths here, 0 cancels 0, 2 here is 1, 2 here is 2. When this one goes up, we now have 2000 minus 10. Now 2000 minus 10 will simply give us that should be 1990. Okay, that's 8990 ohms. Okay, so which of the options best describes the answer, which is option B? So questions on resistors are being dealt with by understanding the concept and knowing the formulas and knowing what to do in problems like this. Now take a look at question 14. For question 14, what is given? The question says 5 times 10 to the power of minus 3 kilograms of a liquid, okay, at its boiling point is evaporated in 20 seconds by heat generated by a resistor of 2 ohms, okay, when a current of 10 amperes is used. The specific latent heat of vaporization of the liquid is, they want us to solve for the specific latent heat of vaporization of that particular liquid. Now it is important to take note that for that liquid to be at its boiling point, it simply means the energy that is coming from the electrical source, okay, or the resistor that is used to heat up the liquid is being converted into heat energy. So for problems like this, we are going to assume that no energy is being lost, and then the heat coming from the electrical source or electrical energy is equal to what now? Heat energy. So I'm going to say the heat energy, okay, is equal to the electrical energy, that is the energy that is generated by the power from the source. Now, since it is at its boiling point, okay, and it's at the point of evaporating, simply means the heat energy will be the mass times the latent heat of vaporization, okay, and then it is equal to what is the heat generated by the power? It is simply what now? Power times time. Now, power, on the other hand, electrical power is current times voltage, or current squared times resistance, or V squared over R, which is voltage squared divided by resistance. So any of these formulas I'm going to write here can be used. We can either have IVT, or for an easy remembrance, we can simply write it as ITV, and then it is equal to I squared RT, okay, or V squared T over R. Now, any of these formulas can be used depending on the parameters that is being given in the question. When you look at the question, the parameters given was current as 10 amperes and resistance 2. So we have just current and resistance, which means we are going to be making use of these two formulas, okay, this one and this one. Hence, we can now say mass times latent heat of vaporization is equal to current squared times resistance times time. Now we're asked to find what? We're asked to calculate the latent heat of vaporization, which means latent heat of vaporization is squared of current times resistance times time divided by mass. Okay, now what is the current? The current is 10 amperes, so we have 10 squared times, what is the resistance given in the question? That's 2 ohms. Okay, so half times 2 times, what is the time? The time given is 20 seconds, so we're going to multiply by 20 seconds divided by the mass given in the question, 5 times 10 to the power of minus 3. Now notice that all of these quantities are in their standardized units, so there's no need to convert. Okay, so you have divided by 5 times 10 to the power of minus 3. 5 times 10 to the power of minus 3. Now can we work with this with ease and see what we are going to get as our answer? Now 5 here is 1, 5 into 20, that gives you 4. Okay, now this 10 to the power of minus 3 can go up. When it goes up, we're going to be left with 2 times 4, okay, times 10 to the power of 2. When this one goes up, becomes positive, times 10 to the power of 3. Okay, 2 times 4, that's 8, times 10 to the power of 2 times 10 to the power of 3, that gives you 10 to the power of 5, using the laws of indices. So 8 times 10 to the power of 5 joules per kilogram. Okay, that is option B, which is same as 8.0 times 10 to the power of 5 in 2, or in 1 decimal place rather. Okay, so that is how a problem like that is being tackled. Okay, the electrical energy is converted to the heat energy, and we're assuming that no energy is being lost. Okay, if you are told that energy is being lost, it will simply mean that the electrical energy will now be equal to the heat energy plus the wasted or lost energy. Okay, now let's go over to question 15. Question 15 says, if the SVP of water, okay, of water vapor was 13.5 millimeter mercury at 33 degrees Celsius, okay, and 7.3 millimeter mercury at 7 degrees Celsius, find the percentage relative. Now this question simply means simply asking us to find the relative humidity. Okay, it was given like this in JAMB exam, that's why I'm not making any changes. Okay, but do know that they want us to find the relative humidity. Now it is saying find the percentage relative of the air on a day when average air temperature was 33 degrees Celsius. Now, if average air temperature was 33 degrees Celsius, okay, on a day, which is, it is not the normal one, okay, or not the regular one we are used to dealing with. Now, it simply means that the dew point is going to occur at 7 degrees Celsius, okay. Remember, the easiest way for you to understand all of these problems is to have studied the topics, okay, and then you can now come to practice these exercises or questions that do come out in the JAMB exams. Okay, so what we are going to do is we are going to solve the relative humidity by applying the formula. Now, relative humidity is equal to SVP. Now, you should know what SVP means. SVP simply means saturated vapor pressure. Now, simply SVP at dew point okay, SVP as dew point, which is saturated vapor pressure as dew point, divided by the SVP, okay, of air at the temperature that I was given, okay, at 33 degrees Celsius. Okay, if it was a different temperature, it would have been that particular temperature. So imagine this was 7 or 25 rather. It would have been what now? 25 degrees Celsius. Now we have to leave our answer in percentage, so you simply multiply by 100%. Now, how then do we deal with a problem like this? Okay, relative humidity is then equal to, now what is the SVP as dew point? Simply the pressure at dew point, which was given as 7.3. So we have 7.3 divided by, what was the SVP at 33 degrees Celsius? SVP at 33 degrees Celsius was 13.5, given in the question, times 100. Now we're still going to do this with our calculator, okay? Still in simple settings, I'm going to have 7.3 divided by 13.5, okay, times 100. That's going to give us 54%, okay, approximately. Now that gives us 54% approximately. So the relative humidity, okay, which measures how much water vapor we have in the atmosphere, is 54%, okay, more than normal, which is supposed to be around 50, yeah. So our answer is option C. Okay, over to the next question, which is a non-calculation question. The question says, electrolysis can be investigated using which of these apparatus? Option A says a voltmeter, option B an ammeter, option C a voltameter, a galvanometer rather, and then option D a voltameter. Now, which of these? The correct option is option D, okay? Now, a voltmeter simply measures voltage, okay? What an ammeter does is that it measures current. And then a galvanometer can sometimes be used as a voltmeter and also an ammeter to measure both, okay? But in general, what a galvanometer does is that it measures tiny amounts of current that cannot be measured by the regular ammeter. A voltameter, on the other hand, is used in electrolysis. What does it do? It helps to measure the amount of quantity, okay, of electricity that is used to deposit a particular metal, okay, in the electrolysis experiment. That is what a voltameter does. So that is also something you should take note of. Okay, question 17 says, a wheelbarrow inclined at 60 degrees to the horizontal is pushed with a force of 120 or 150 newtons. What is the horizontal component of the applied force? Now there are options here. The question is quite straight. What we want to do first of all is to draw a free body diagram. A free body diagram is a diagram that shows what the question is describing, okay? So it's like we are drawing a force, okay, along an inclined plane, and we have to find the horizontal component. Now they said if wheelbarrow is inclined at 60 degrees to the horizontal, okay, so let's say this is the wheelbarrow, okay, and it is inclined at 60 degrees to the horizontal. This is 60 degrees. Now since it is being pushed, definitely it is being pushed up the plane, right? Either up or down the plane. So if it is being pushed up the plane like this, parallel to the plane with a force F, and then we're asked to find the horizontal component. So find the horizontal component. Since it's inclined at 60 degrees to the horizontal, it means we're just going to resolve it like this down to the horizontal. So the horizontal component then becomes F cosine of the angle theta. Now, what is the force? The force is given as 150 newtons. So I'm going to have 150 newtons cosine of 60 degrees. Now, the cosine of 60 degrees is 0.5. 0.5 times 150 gives you 75, okay? So half of 0.5, half of 150 rather, would give you 75 newtons. So the horizontal component of the force is simply option B, which is 75 newtons. Now, question 18. In a solar panel, solar beam is concentrated by using which of these kind of mirrors? Is it a concave mirror, a convex mirror, a plane mirror, or a triangular mirror? Now, there's basically nothing like a triangular mirror, okay? Now, we also have a plane mirror. A plane mirror produces an image that is exactly same as that of the object, same size, same height, same distance from the object, okay, and to the mirror. Now a convex mirror produces only one kind of image, okay, that it is virtual, it is erect and diminished, while a concave mirror on the other hand, produces different kinds of image depending on the position of the object, okay, and it is best also the one that is applied in the concentration of solar panel. Now, how it works is we are going to place the concave mirror in such a distance from the solar ray such that the highest intensity or the maximum intensity is being focused on the solar panel to help accelerate electrons through photoelectric effects. That is why it is used in photoelectric devices. Okay, now which means the correct answer to question 18 is A. Now the next question says a rectifier is a device that changes which of these. Now take note that a rectifier changes AC to DC. Okay, that is what it does. It converts current or voltage from AC to DC. Now we do know that an AC current moves to and fro. Okay, if you see the symbol of rectifier, it's usually given as this. Okay, this is what a rectifier looks like. The reason why a rectifier is able to convert AC to DC is simply because as the current is moving to and fro for a regular device, when it gets to a rectifier, once it moves in one direction and tries to come back, it is being blocked by parts of the rectifier. Okay, hence it cannot produce current in the backward direction. So we only see current moving in one direction. That is why we say it helps convert current from AC to DC, so there is no fluctuation. Okay, since it is volt now very high, there is no breakage in the current. Okay, so a rectifier basically converts an AC into a DC. Okay, that is what a rectifier does. Now for number 20, the question says the dimension for Young modulus E is given by. What is the dimension for Young's modulus? Now, Young modulus generally is given as stress over strain, right? We do know that Young modulus E is given as stress, okay, over strain. Now, what is stress? Stress is simply what now? Force divided by area. And that is force divided by area divided by what is strain. Strain, on the other hand, is extension divided by original length. Now you should know that strain does not have a dimensional quantity. Okay, since it does not have a dimensional quantity, we can then leave it out. Okay, now this guy is out of the picture. We are left with force over area. Okay, now force, on the other hand, is mass times acceleration divided by area. The dimension for mass is capital letter M. The dimension for acceleration is LT minus 2 divided by the dimension for area is L squared. Now one L can cancel out one L. We're now left with M. This L can go to the top, giving us L minus 1. And initially we're having T minus 2, which means the dimensional quantity for Young modulus is ML minus 1 minus 2, and that is option C. Okay, now look at this question 21. The question says the moon's acceleration due to gravity is 1/6 of the Earth's value. Okay, the weight of a bowling ball on the moon would be. Now this is a kind of a straightforward question. Okay, the question simply says the acceleration due to gravity of the moon is that of the Earth divided by 6. Okay, what would not happen to the weight of a ball, okay, that we are going to weigh normally here when we take it to the moon? What will happen to the weight? Does it increase? Does it decrease? And if it increases, by how much? If it decreases, by how much? Now you should know that weight is directly proportional to acceleration due to gravity. Okay, since weight is equal to mg, means as gravity increases, acceleration, or rather weight tends to what now? Increase. Okay, mass is always constant anywhere. Now as gravity increase, weight increase. Now since the moon's acceleration, okay, is 1/6 of that of the Earth, it simply means that it is smaller than that of the Earth, which means the weight also will be smaller. By what amount? Since they are directly related, by the same amount. So the best option will be, it is going to be 1/6 of the bowling ball's weight in the Earth. Okay, so which of these options? I can see 1/6 of its weight on the Earth. So that is definitely option B. Okay, that is the fastest and easiest way to solve a problem like this. And then question 22 says, if a sheet of an insulating material is inserted between the plates of an air capacitor, the capacitance will. Now it is important to take note that most persons tend to face this question simply because they don't understand or they don't have a basic knowledge of how capacitors and dielectrics work. Okay, now a capacitor is simply a plate, two parallel plates, okay, spaced at each other, or they are separated by an insulating material. Now take note that air can also be used as a dielectric. That is, the plates will be placed so close but they will not touch each other. Okay, but when we bring in a non conducting or an insulating material, the dielectric effect becomes very much active. That is, the material that is placed between the plates in the capacitor helps to increase the dielectric effect. Okay, then the capacitor now helps to what now store more charge, hence the capacitance is being what now increased. Okay, so whenever we place a non-conductor and insulating material between two parallel plates in the capacitance tends to increase. But by what value does this increase? Take note that it increases by the relative permittivity. Okay, it increases by the relative permittivity. Please take note it's a constant, which is the ratio of permittivity of a medium to permittivity of free space of vacuum. Okay, take note that the capacitance tends to do what now? Increase. And then we are left with the last question on the board, which is question 23. Okay, question 23 says 288 kilo joules is conducted across opposite faces of a 3-meter cube of temperature gradient 90 degrees Celsius per meter in 7,200 seconds. Calculate the thermal conductivity. Okay, that is what the question is asking. Option A is 4.9. You can see the various options here. Now, to solve for thermal conductivity, all you simply have to do is know the formula. Okay, what is the formula for calculating thermal conductivity? Now, we do know that for power in terms of conduction is equal to thermal conductivity times area times temperature gradient. Okay, that is the formula. Where A is the thermal conductivity, P is power, A is area. Where K is thermal conductivity, P is power, A is area, T is temperature, and L is length. Okay, where T over L is the temperature gradient, which was given as what now? 90 degrees Celsius per meter. Okay, so to solve for K in this case, K will then be equal to P times L divided by A times T. Okay, that is what K will be equal to. But how do we know the value for P? Okay, how do we know the value for P? P is simply power, that is work over time, right? So we can come here and replace it to work over time times L divided by A times T. Now you notice that L over T is now the reverse of temperature gradient. Temperature gradient is supposed to be T over L. Okay, we are now having L over T. So let's rewrite this formula as K is equal to W over T times, or rather W over T divided by area times T over L. So we can now have what now? Temperature gradient. Now what is the work? 288 kilojoules. So I'm going to have K is equal to 288 times 10 to the power of 3, where 10 to the power of 3 represents what now? Kilo, divided by, for how long? 7,200 seconds. So we have 7,200 seconds, all divided by, what is the area? It was a cube. Okay, so what will be the area? Length times breadth. The sides are equal, so you have 3 squared. That would be 3 squared times, what is the temperature gradient? That is what now? 90. Okay, so when we do the maths, for this, we are going to have 288 times 10 to the power of 3 divided by 7,200. Okay, we'll get 40, and then divided by 90. Okay, and then divided by 3 squared, which is 9. So I'm going to get an answer of 0.049. Okay, 0.049 approximately. So our value is 0.049. This can be written in standard form as 4.9 times 10 to the power of minus 2, and here is the unit, watts per meter per Kelvin. So option A is the correct answer. Over to question 24. The question says, a sonometer's fundamental note is 50 Hz. What is the new frequency when the tension is 4 times the original? Now, to solve a problem like this, you should know how sonometer frequency relates with tension. Okay, now you should take note that the frequency of a sonometer, okay, is directly proportional to the square root of its tension. Now, the question I will read again says a sonometer's frequency note is 50 Hz. So when F is 50, what is the new frequency when the tension is 4 times the original? Okay, so we are going to say F is directly proportional to the square root of tension. Okay, and then from here it means we are going to be having F1 over square root of T1 is equal to F2 divided by the square root of T2. Now F1 is 50. Okay, now the initial tension we are going to call it T. We are going to solve for F2 according to the problem, and then T2 is 4 times T, right? So we are going to get 4T. From here, we are just going to simplify. So we have 50 divided by square root of T is equal to F2 divided by the square root of this can be written as square root of T times square root of 4 is what now? 2. Square root of T cancels square root of 4. So it means F2 is equal to 50 times 2. That gives us what now? 100 Hz. So the answer to this question is option B, 100 Hz. Now we look at question 25. The question says, which of the following is not part of a model rocket? Okay, option A, the body tube. Option B, the nose cone. And then option C, the fins. Why D says non-recovery device. Okay, option D says non-recovery device. Now, non-recovery devices are actually devices that are not the general ones we are having. Okay, they include devices like the parachutes, streamers that are used in gliding through the winds. Okay, those are non-recovery devices, and these ones are actually rocket model. Okay, that is a real aerodynamic device. Okay, that uses probably fuel or by electrical means. Okay, so option A is the body tube. We have the nose cones, we have the fins, of which option D is the answer. Okay, because it's different from the other ones. Okay, now question 26 is a thick glass tumbler cracks when boiling water is poured into it because why does a thick glass tumbler crack when water is poured into it, or hot water to be precise? This is because there is an uneven expansion between the inside of the glass and the outside of the glass. That is, the inside of the glass expands more than the outside of the glass. Okay, so that is the answer to question 26. Question 27 says, how much joules of heat are given out when a piece of iron of mass 60 gram and specific heat capacity 460 joules per kilogram per Kelvin cools from 75 to 35? Okay, now to do that, we're going to make the formula H is equal to mc change in theta. Okay, of which m is the mass, c is specific heat capacity of iron, and delta theta means change in temperature. Now, what is the mass given? Remember, the mass was given in grams. We have to convert into kilograms. Okay, and this degree Celsius does not really matter in terms of conversion if you're converting it to Kelvin or anyone to degree Celsius. This simply because we are going to be taking temperature difference. Temperature difference does not really affect temperature conversion. Okay, so I'm just going to say H is equal to, what is the mass? 60 gram. Remember, it's in grams, so I have to convert to kilogram by dividing by 10 to the power of 3. Okay, times specific heat capacity was given as 460, so we have times 460 times change in temperature is 75 minus 35. Okay, that's what we're having on the board. So from here, we just do the maths on our calculator. That's going to give us 1104. Okay, so the energy or the heat is 1104 joules. Now the next question here wants us to calculate the energy of light of frequency 2 times 10 to the power of 15 Hz. We are given Planck's constant. Now for radiation such as light, there is a formula for calculating the energy in relation to its frequency. Now it is important for you to take note of the formula. E is equal to H times F, where H is the Planck's constant, which is 6.63 times 10 to the power of minus 34, and F is the frequency. So to get the energy, we just have to multiply those two numbers together. That is going to give us 1.326 times 10 to the power of minus 18. So we're going to get an answer or a value of 1.326 times 10 to the power of minus 18 joules. Now, this value is in joules. We could as well put it in electron volt, that is by dividing by the charge of an electron. Okay, so depending on the option. Now, question 29 says a mass of gas at 40 millimeter mercury is heated from 298 Kelvin to 348 Kelvin. Remember, you have to convert. Okay, it's already in Kelvin. At constant volume, calculate the pressure exerted by the gas. Now, since it's at constant volume or given pressure and temperature, simply means it falls under pressure law, which says pressure is directly proportional to temperature. And if pressure is directly proportional to temperature, it simply means we can now have P1 over T1 equals P2 divided by T2. Okay, so P1 from the question is given as 40. We're going to have 40 divided by, what is T1? 298 equals P2 divided by, what is T2? 348. Okay, so from here we can now solve for P2 just by cross multiplying. That's going to give you 46.71. okay, for the pressure. So the pressure is going to be equal to 46.71 millimeters of mercury. Okay, over to question 30. The question says the distance between two successive crests of a water wave is 0.25. Now take note, they said distance between successive crests. Remember, from definitions of wave, distance between two successive crests or trough simply means what now? A wavelength. Okay, so they've basically given us the value of the wavelength, okay, for the question. So the wavelength is now what now? 0.25. So we can now say wavelength is equal to 0.25. Okay, and then they say again, if a particle on the surface of the water makes 4 complete vertical oscillations in 1 second, what is the definition of a frequency? The number of oscillations made in 1 second, that is the definition of a frequency. Okay, which means that the frequency in the question is now what now? 4. That is F is equal to 4. We are asked to find the speed of the wave. The question says calculate the speed of the wave. Now, the relationship between velocity or speed and frequency and wavelengths is that V is equal to F times lambda. So V is equal to, what is the frequency? 4 times 0.25. Now 4 times 0.25 is 1, okay, meters per second, which means the answer to this question is 1 meters per second. The speed of the wave is 1 meter per second. And then question 31, the thermometer whose thermometric property is change in volume with temperature is, okay, that's the question. Now there are various thermometers that work on different principles. Some work based on resistance, some based on light intensity, some based on infrared radiation, while some based on some thermometric or liquid properties. Okay, in this case we have been asked the thermometer whose thermometric property is in change with volume of temperature. Okay, which of them is it? Simply the liquid in glass thermometer. Okay, particularly those ones that make use of liquids like mercury, okay, which expands as temperature changes, that is, they have a very high thermal conductivity. So it's a liquid in glass thermometer. Okay, a liquid in glass thermometer. That's the answer. Now the next question, in a series resonance circuit, the current flowing in the circuit is maximum. Okay, not just maximum, there are other things that comes in hand with when there is resonance occurring in an AC circuit. Okay, now what is that which comes in hand? The current is maximum, that is at its highest. Inductive reactance equals to capacitive reactance. Okay, current is maximum and the resistance is having its least possible value. Okay, so in this case we're talking about the current, so we can now see that it is what now? Maximum. Okay, question 33. If a body in a linear motion changes from point P to Q, the motion is, okay, now there are different kinds of motion: rotational, translational, oscillatory, and the likes. Now the question says in a linear motion, which means it's a straight path, so it can never be rotatory or rotational or circular, okay, or even SHM, because they said linear. Now from point P to point Q, what kind of motion is that? Simply what now? The translational motion. So question 33, it is what now? A translational motion. Translational motion is simply what now? The change in position of a body from one point to the other. And question 34 says, which of these gas laws is equivalent to work done? Okay, we have Charles, pressure, Boyle's, and de Lusac. Okay, the answer is simply what now? The Boyle's law. Okay, the answer is the Boyle's law. Why is it the Boyle's law? Well, we can prove it from the formula. We do know that Boyle said that the pressure is inversely proportional to what now? Volume. Beginning the constant PV is equal to what now? Okay, it is from here we can now have P1, V1, P2, and V2. Okay, now what if we don't choose to do that? Pressure is what? Force over area. So we have force over area. And volume is area times what now? Height or distance, right? Area cancels area. We are left with force times distance, and force times distance is what now? Work done. That is why Boyle's law is regarded as what now? Work done. And then the last question on the board, which is 35. The process of addition of impurity to a semiconductor material to increase its conductivity is called doping. Okay, it is called doping. Doping is the process of increasing the conductivity of semiconductors, okay, by adding the group 3 or group 5, which are trivalent or pentavalent elements, respectively, on the periodic table. Okay.
For question 36, it says a load of 300 newtons is to be lifted by a machine with a velocity ratio of 2 and an efficiency of 60%. What effort will be applied to lift the load? Okay, this is a problem on machines. Okay, the problem is saying that the load is 30 newtons. This is the load that is to be lifted by the machine, and then the velocity ratio is given as 2. The efficiency is 60%. What will be the efforts you require to lift the load? Now, efficiency is equal to mechanical advantage over velocity ratio times 100%. Okay, so let's first solve for the mechanical advantage. Mechanical advantage from this formula, when we make it the subject, is going to equal efficiency times velocity ratio divided by 100. Okay, so mechanical advantage is efficiency, which is 60, times velocity ratio 2 divided by 100. Now this reduces to 1.2. Now mechanical advantage on the other hand, we know it is load over effort. Okay, now what is the load given in the question? 30 over effort equals 1.2. For me, effort is 30 divided by 1.2. Now what will be 30 divided by 1.2? Okay, we're simply going to work it out using our calculator. So I'm going to get 30 divided by 1.2. That will give us 25. Okay, so get what now? Effort as 25. So for this question, effort is equal to 25 newtons. Okay, next question. The average translational kinetic energy of a gas molecule depends, take note, the translational kinetic energy of a molecule depends only on temperature. Okay, it depends only on temperature. Now, next question. The fourth overtone of a closed pipe is 900 Hz. Its fundamental frequency is. Now, for a closed pipe, it is important that you take note that the overtones are always odd. That is, the first overtone. The first overtone is 3 times fundamental frequency. Okay, second overtone is 5 times fundamental frequency. The third is 7 times fundamental frequency. And then the fourth overtone is 9 times fundamental frequency. So since we are giving the fourth overtone as 900, so fourth overtone, which is 9f naught, we are giving as 900. So 900 is equal to 9f naught. 9 cancels 9, so we are left with f naught is equal to 100, which means the fundamental frequency for this question is 100 Hz. Okay, now the next question. A cell of internal resistance 2 ohms supplies current through resistor X. If the efficiency of the cell is 75%, find the value of X. Now, efficiency of a cell is important that you take note of this formula. It is external resistance, okay, divided by internal resistance plus external resistance times what now? 100. We are asked to find R. So from here, we are going to substitute 75 and then internal resistance is 2. So I'm going to get 75 is equal to R divided by 2 plus R times 100, okay? Dividing both sides by 100. 75 over 100 is 0.75 equals R divided by 2 plus R. When you cross multiply, you get 0.75 times 2 plus 0.75 R equals R, okay? So for me, I want to collect that terms. We have 0.75 times 2 equals R minus, take this one to the other side, 0.75 R. So we have 0.75 times 2 equals, when you subtract this, what do you get? Okay, 1 minus 0.75 is going to give us, you're going to get 0.25. We get 0.25 R. For me, R is equal to 2 times 0.75 divided by 0.25. And we'll do the math. What then are we going to get? We're going to get 2 times 0.75 divided by 0.25. That will give you 6. Okay, which means the resistance or the external resistance for this question X is what now? 6 ohms. That's why I put it like this in this one. And then for the last question, question 40, it says 12 point charges Q are placed at the 12 edges of a polygon. What is the resultant force on a charge Q minus, okay, at the center? Now in here point charges, please take note that they mean what now? Positive charges. They are used as what now? References in electrostatics. Okay, if they are placed at the 12 sides of a regular polygon, which is having equal sides, okay, equal lengths of sides, and then a charge Q minus is placed at the center, each of those charge is going to what now? Be attracted to this charge that we're having here. Okay, each of those charges is going to be attracted by those charges that we're having here. Because of that reason, each of them will try to pull on it. Okay, let's say we are having 4 charges, for example, and one antenna. This one is going to pull on this one is going to pull on this is going to pull on this, and this is going to pull on this. Because all the 12 charges are pulling on the one on the center, the forces in opposite direction tends to cancel out. 6 charges produce 6 force, and they cancel out the 6 force that is produced on the other end. So because all the forces cancel out, it means what now? The net charge on the charge that is at the center is equal to what now? 0 newtons. And that is how a problem like this is being solved. So far, for those persons that stick through the end of the video, the 40 questions that took us time to solve, or still we aced through all of them, I'm sure you learned something. Now if you didn't learn something from the video, do it to smash the like button, share this video with your friends that are writing jams, pursue TME, or further examinations that are to come. Okay, if you also have a question, put it in the comment section, and don't forget to subscribe, click on the notification bell so that our next video is being uploaded, you'll be one of the first 2 persons that will get notified about it. See you in the next video. Bye.